To join a live broadcast of Python Live Lessons, tune into my YouTube channel Sebastiaan Mathôt every Tuesday, 10 p.m. New Delhi time, 6 p.m. Central European time, and 9 a.m. Los Angeles time. Hope to see you then, and for now, enjoy this episode. Hi everyone, thanks for tuning in to the premiere, episode 0 of Python Live Lessons. So I'm very happy to start this new format. I've already been posting YouTube videos for a while, quite intermittently, I have to admit, usually about Python code. And I felt for no particular reason that it would be nice to do this in the form of a live show. So Python Live Lessons will be a weekly show every Tuesday at 6 in the evening Central European time, and we'll cover various things related to Python coding. And Lisa is asking, so we have a chat here, that's one of the nice things. This series sounds amazing. Will the tutorials also be available afterwards? Yes, absolutely. So they will be recorded, and then afterwards they will just be available as regular Python videos. All of this is a little bit new for me too. Right? This is my first live YouTube thing. But that's my understanding. So there is a chat. The round trip time is about 20 seconds. So if you ask a question on the chat, please do. But if I don't reply right away, that's not only because I'm being rude, but also because of the round trip time. Okay, but let's start with a little bit of introduction just for this first tutorial, first episode about myself. So who am I? My name is Sebastiaan Mathôt, and my day job is being a cognitive neuroscientist. What does that mean? It means I work at the University of Groningen, as an assistant professor. And there I teach psychology courses to students, of course. And a big part of my job is also doing research. And in terms of research, I study visual perception, things like attention. So how do you attend to things? Eye movements. How do you move your eyes? Why do you move your eyes? And I also focus very much on one specific thing, namely changes in pupil size. So little changes in the size of the eye's pupil. And in doing research, a very big part of research in this field and also many other fields is software. So there's another side to my work, and that is that of developing scientific software. So I develop open source scientific software for conducting psychology experiments, for doing data analysis, etc. And most of that software is created in Python. So that is where my affinity with Python comes from, and where also my experience with developing Python code and managing Python projects comes from. And I hope with this series that I can sort of combine the teaching element, right? So I like teaching to students, to people on YouTube Live, whomever you may be, and combine that with my affinity for developing software in Python. Something I also do on occasion is consultancy. So that means that companies can hire me. And then, generally speaking, I help them to set up some kind of software project in Python, usually, that they need internally. And a lot of these things nowadays, as many of you probably know, focus on things like machine learning, data science, etc., those kinds of things. So sort of artificial intelligence, data science software projects. And thanks actually for everyone who's tuning in. I'm pretty excited. I was actually not sure how many, if anyone, would tune in to this live series. I'm happy to see some activity in the chat. So what are we going to cover? What kind of things can you expect in Python Live Lessons, the series, in this episode, but also the next ones? Lots of Python, right? So we're going to really sort of take a look at the language, and I hope by watching this series, you will learn to become a better Python programmer, or if you have no experience yet, to learn how to program. But we're also going to focus very much on a workflow. So it is not only going to be about writing short scripts that work well in Python, but also about the broader landscape of software development. So how do you set up a Python program from the beginning to the end, right? How do you manage your Python project, etc.? And one part of that workflow is packaging. So how do you build a module, a Python module, and how do you then package it so that other people can install it? A lot of you have probably worked with pip to install things, and then you say pip install, the name of the package, and then you have it like magic. But of course, someone needs to put that package on pip or on PyPy, as the repository is actually called. And that is what packaging is about. So how do you actually make your module such that other people can pip install it? It's not that hard, actually. Debugging, right? So all code, all Python code is buggy. That's part of life. But how do you, if you encounter a bug, how do you deal with that? And there are various ways to debug code, right? From simple print statements, which a lot of people use, including myself, to using the so-called breakpoint keyword or function in your Python, to using a proper debugger, which is a dedicated tool to spotting bugs in your code. Testing, right? So debugging and testing are related, but they're not the same, right? So if you have a bug, maybe your code just crashes and you need to debug it. But even if your code doesn't crash, there may be bugs in there that you don't actually know about because your code seems to run fine. It just doesn't do exactly what you want it to do, right? You ask it 1 + 1 and it gives you an answer, but it says 3 instead of 2. And then maybe you don't notice. So testing is and so-called unit testing is a more or less systematic way to make sure that your program actually functions in the way that it should function. And data science will also be a part of the series. So my own background, right, as a researcher, as a consultant, as someone with a general interest, is very much data science. So a lot of the software that I develop has something to do with data science, and as such, that will also be a recurring theme. What is data science? Well, it is any kind of software development that has to do with number crunching, right? It can be deep learning with TensorFlow, but it can also be doing statistics, or it can even be just working with simple numeric data, anything. So that's what you can expect. More concretely, we're going to actually really develop a project. So this episode is called Starting a New Python Project. And what is the project that we're going to start? It's called Markdown Code Exec. And what does it do? That will become clear later on. But it's going to solve a problem that I personally often run into. And what is that problem? Well, it is that I have a piece of Markdown, and Markdown is just text that people write often to document code. And in that piece of Markdown, for example, I have a README file that explains how a particular Python module is supposed to work. And in that README, there will be a chunk of code that demonstrates, it's an example of how that code should work. Now, what I would like is that our program that we're going to create, Markdown exec, actually takes a Markdown file like that, takes the chunks of example code in the Markdown, executes them, and inserts the output of that code into the inserts the output of that back into the Markdown file. So in a way, it is almost compiling the Markdown file by actually executing the code and inserting the output into it. That's what I would like. And it has a very clear use because it means that I can write README files to document my code that has these examples in it. And rather than manually copying pasting the output for those examples in the README, I just use my Markdown Code Exec tool to do that for me. That is the goal. How are we going to approach that? Well, today we're going to actually start with this sketch. And I should have already said I aim for episodes of around 30 minutes, so relatively short. Which means that we're not going to get much further than the beginning of a sketch. What is a sketch? A sketch is basically a rough, not polished piece of code that approximately does what we want the code to do. For a simple project, it is useful to write a sketch, right? For a simple project that lends itself to this kind of sketch approach. Once we have this kind of rough piece of code, in the next episode, not today, we won't get to that, but in the next episode, we're actually really going to see how we can take that sketch and turn it in something that's a bit nicer by turning it into a function and putting that function into a module until the code more or less has the format that the Python user is used to, right? So that it has the format where you can say import markdown code exec and then call some kind of function by saying markdown code exec dot compile or whatever we want to call it. We will also take a look at how you can use Git, right? So I always use Git to maintain my software. So what is Git? I'm sure a lot of you are familiar with it. Basically, Git is a what they call a versioning tool that systematically keeps track of all the changes that you make to your code. So basically, every time that I polish something to the code, I use Git to say, okay, now I changed something, I want to save that change, I want to commit it, as they call, and in that way I keep track of it. And then Git is often used in combination with GitHub, which is a website that you can then synchronize your code with. This sounds very abstract and also a little bit superficial probably to those of you who've actually used Git and GitHub, but we'll take a look at it in more detail in later episodes. Because using Git is really a very important tool in your programming toolkit, even though it is a bit hard sometimes actually. And then we're going to take a look at packaging at the end. So at the end of this few series, I don't know how many episodes it's going to take, say 4. What I want to have is a package called markdown code exec, or maybe if you have a better name, I'm open to suggestions, that people can pip install, right? So that you can say pip install markdown code exec, and then in a very easy way, use that in your own code. That's the goal. All right, so that is what we're going to do. So, and today I want to introduce the goal. So I will show you a little bit what I want the markdown code exec program to do, and we'll make a sketch, and that's about it. Then we will have spent approximately 30 minutes, and the episode will end. And in the meanwhile, there's a lot of multitasking for me going on. I'm trying to monitor the chat. I will have to talk. And I will have to do some coding at the same time, all live in a format that I'm not entirely familiar with. So let's see how well that goes. All right. Up. Jump. I am being helped. Hello, Doc Obelix. Nice to sort of meet you. I'm being helped actually by an amazing tool called OBS, Open Broadcasting Studio, which makes this kind of live streaming amazing, and it's an open source program showing kind of the power of open source software. I'm not sure it's programmed in Python, maybe not, but let's say that it is. Vishal asks, what's the duration of the lecture? It will be 30 minutes. So right now we still have, say, 18 minutes to go. It may be, say, 35 or 25, but that's about what I'm aiming for. So pretty short. It also needs to be manageable for me, of course. Okay. So, a code snippet like this should not be processed. Okay, I should say, what you're looking at now is Markdown. This is a piece of text, and this is the kind of input to my program, to our program. This is just regular text, and according to the Markdown format, anything that is between these triple backticks is code. So this triple backtick says here code should start and here it should end. And what's in between this print statement, that is actually code, Python code. Now here it says print, leave this alone because we don't want this particular piece of Python code to be executed. We only want Python code to be executed when it is actually specified in the markdown file that it should happen. So there is a capture flag that you can specify. And if you do that, then the output should be captured. The code should be, Visual, we're not actually going to get, we're only going to get a little ways in the direction of the full program in 30 minutes. But that will fit, I think. So the capture flag is this thing here. So what I would like our program to do is say, okay, if we have a bit of if we have a code piece, then we specify some attributes. And attributes are things that follow the backticks between these curly braces. Why? Well, that's how it's defined in Python Markdown. So I'm just sort of following the syntax that Python Markdown uses basically here. And there are different sort of flavors of Markdown. They may not all actually accept this, different dialects, if you will, but Python Markdown does. Then inside these curly braces, you can give some properties of the code. So we can say .python. That means that it is Python code, because in principle we could also put JavaScript, for example, in there. But this is Python. And then we can put arbitrary other attributes. And this attribute is going to be capture. And that capture attribute, that is what our Markdown code exec program will listen to. And it will actually use that to execute this code and then capture the output. And what should happen then is the following. So our program should programmatically do what I'm doing manually now. So it should put this here and this here. So I hope you see the logic, right? So it is actually executing this code. What it will do is print out two very simple things. This output should be captured and this too. That output should be put again inside a code block with these backticks. And there should be a little prefix, or however you want to call it, out colon, to indicate that that's actually the output. That's what we like it to do. I could do this manually, but I don't want to do it manually. I want the Markdown exec to do it for us. We can also specify a silent flag. And the silent flag means that the code should be executed, but the output should be captured. But it should actually not follow the code, but it should replace the code. So here, this is basically a silent cell. That's the output, and it should just replace the whole thing. That's how that flag should work. That's the behavior that we want. And why? Well, that allows us to basically generate Markdown code on the fly, right? Then we could have a bit of Python that actually generates the Markdown. And Nick Wood said that he's a biostatistician who's a bit confused by GitLab, so I hope this indeed will clarify things a little bit for you. Welcome, in any case. And we have a third flag called exception. And if we pass that, then we say the code should actually raise an exception, because sometimes we want to illustrate how things crash. For example, if you execute this, that would crash. And then we want to gracefully capture that exception and handle it. All right, I hope it's clear how the program should behave. So let's now take a look at how we're actually going to implement it. So let's create a sketch. Right click, new file, sketch.py. So, and now I'm going to use a term that is going to scare many of you, namely regular expressions. We're going to use regular expressions. And what is a regular expression? A regular expression is a way to match a particular pattern on a piece of text. That sounds abstract, but let me explain what it means. Say that you have some Markdown and it's like this. This text has some italic text in it. So here we have a string. And if you know Markdown syntax, you know that it means that some should be italic and text should also be italic. That's what the asterisks mean. A regular expression would allow us to search and capture specifically those things. So we specify a pattern that matches italic text here. This can be very complicated, but I hope to actually walk you through this and to show that regular expressions, if you take them slowly, one step at a time, are a good way to do this. You think maybe right now, well, why don't I just create a loop that goes through this text string one character at a time? That would also work, actually. In many cases, that also works. But regular expressions are more aesthetically pleasing, more elegant, and they can also do much more complicated things that are difficult to do by just looping through the text. So what I will do now is basically explain a simple case of matching with this text has some italic text in it, and then we'll generalize that to actually creating a regular expression that captures these what is called fenced code blocks in the Markdown text between the backticks. So we need to define a pattern here like this. And the pattern is a raw string. So R means that in Python you say, okay, the string that will follow is a raw string, which means if you do something like this, /t, normally that would become a tab character, But if you say it's a raw string, it will not be interpreted and it will just be a slash followed by a T. Inside that raw string, we're just going to sort of describe what we're looking for. So we're looking basically for something between two asterisks. So that's a good starting point. Now, the asterisk itself has a special meaning for a regular expression. It means something that happens 0 or more times. So if we want to literally search for an asterisk, we put a slash for it in front of it. We escape it. So now we're searching for two asterisks. There should be something in between the two asterisks. What? Well, anything basically can be in between. And a dot means anything. So now we have two asterisks with anything in between. But that anything is just one character, and there can be more characters in between. How many? One or more. Plus means one or more. So now we say any one or more of anything between two asterisks. That is what this means. This, in principle, is already a valid regular expression. So how can we now use this regular expression to actually apply it to the text above? First, we need to import the regular expression module. And then we are going to do it like this. I will type it and then you can follow along. I will say for match in RE, that's the module, right? Regular expression. Find iter pattern, comma, MD. Print match. Okay. So this means find iter is the function from the regular expression module that iteratively, so repeatedly, searches for a pattern in a haystack, you could say. In this case, our markdown string. And then it returns match objects that have some information regarding stuff that matches. Now, what I will do now, just a little bit of a trick. This hashtag followed by 2 percentage signs is what you can use in Rapunzel, but also other editors such as Spider, to separate cells of code that you want to execute together. So this means that if I now am here and I will click on this quick run button, it will run all of this code together. Let's see how this works. Up. Okay. And now you see at the bottom, the IPython terminal appears. And what has effectively happened is that this code that I wrote is copy pasted into the terminal and executed as if you would have typed it there. So here, this. And the output, and that's a bit annoying I find, but that's the way it is always above rather than below the stuff that's executed. So this is the output. So there is one match object. And what did it match? Well, it matched from character 14 to 34, and it actually matched some italic text. Oh, that's not what we wanted, right? We wanted to match some and text, but not this whole thing. So what went wrong here? Well, this is important to know about regular expressions. They are greedy. What that means is that we said we want something that is preceded by an asterisk and ended by an asterisk with as much stuff of anything in between. That's by default what it means. But actually what we want something that is preceded by an asterisk and ended by an asterisk with as little of anything in between. We want non-greedy matching. How does that work? We simply say question mark. So this means of anything, one or more occurrences, don't be greedy. I hope that's clear. And then if I execute that, you will see it will go closer to the behavior that we want. So we're matching some and we're matching text. So that's pretty good, right? But actually, what we want is not to match the whole thing, including the asterisks. We want to get the words out of it. Just like later, we want to get the code out of the fenced code blocks rather than having sort of everything, including the backticks. So we want to somehow get the part of the expressions that match only this. How are we going to do that? We can do it like this. Up. Word. This is not very nice to look at, right? To say the least. But it's also not super complicated. What it means is we give a name, and the name is word. And this question mark here indicates that this is the name we're going to search for. Oh, I'm typing it incorrectly. Question mark P word, that's what it should be. And everything between the parentheses is going to be called word. So the characters, one or more characters, are going to be called word. And if I now don't print out the match object, but I print out what is called the group word, you will see that I selectively pick out this little piece. So I will only get the words. So I'm matching quite a big thing, namely including the asterisks, but I'm only interested in the small thing in between. All right, let's execute this. And now you see in the output, indeed, we're only getting sum and text. Right, so now this was a very quick 101 regular expressions. And the goal in general of these episodes is not going to be to sort of delve into one topic in a lot of, thanks actually, and to sort of delve and go into one topic in a lot of detail, but just describe the topic, regular expressions in this case, in sufficient detail that you can see how you can actually apply it to this project and hopefully also your own projects. So let's now actually go to our file. So now we want to do something similar, but we want to actually do it in a more complicated way by matching these kinds of things. The first thing that we need to do is actually read our file. So I am going to say with open demo.md as fd, md is fd.read. If I execute this, run, you will see there's actually no output, but what has happened is that md it now contains the contents of demo.md. I hope you're familiar with this. So open is for opening a file. We open the file as fd. We read everything from the file and we assign that to Markdown. If I look, just to make it easy, here's the Workspace Explorer that shows all the variables that live in my Python workspace. If I click on MD, you can see that it actually now contains the contents of that file, as you would expect. Okay, let's close that. Now we need to define a new pattern that actually matches what we want to match. So let's actually, just to make it, put them side by side. So let's start here, right? Here we have the thing that we want to match. What kind of pattern do we now actually need to define in order for this to be successfully matched? Oof, exciting. So the pattern, let's close this so I have a bit more real estate. The pattern is going to start, is a raw string again, and it is going to start with some backticks, 3 of them, followed by a new line. And then we have some code here. And what is the code going to be? It can be anything, and it can be 0 or more of anything, followed by a new line here, so basically this. And then there are 3 more backticks. This, in principle, matches these kinds of code blocks, but not perfectly. Actually, this pattern would match this code block because it actually is 3 backticks and then some code and then 3 more backticks. But it is not yet good enough to match this because here the backticks are actually followed by these curly braces and the attributes inside it. So we want to be a little bit more specific. So what we want to have here after the parentheses, the backticks, something that matches these attributes. So we need to have first take into account that there can be some white space. A white space is /s. 0 or more white spaces can follow. Here we have 1 space, but someone is also allowed to have 2 spaces, right? We're not going to be too picky. Then we have curly braces open, curly braces closed. That literally refers to the curly braces, right? So here, this one and this one. Then also we're going to be kind of liberal and also at the end allow some white space. So /s 0 or more, just in case someone had some sloppy spaces at the end. Can happen. We don't want to punish someone for that, right? Oh, oops. And then in between the curly braces, we need to specify what is actually allowed in there. Now, what is allowed in there? A dot is allowed in there for the Python. Letters are allowed in there. Numbers are allowed in there. Spaces are allowed in there. Underscores are allowed in there. And that's about it. So how can we specify that? We say these square brackets are going to allow us to define a set of characters that are okay, that we want to match. One of the characters is a dot for the dot Python. One of the characters is a space, literally a space. A to Z means the regular expression will understand that that's every lowercase letter. A to Z is every uppercase letter. 0 to 9 is every number, and an underscore. So this thing matches any character that's in there. So it's a bit of a verbose way to sort of make a selection of characters that are allowed there. Then I say a plus for saying we want to have one or more of those characters in there. Right? So we want to have one or more of these things in here. And only then do we want to match it. This is about correct, but we want to be a little bit more picky. Because these backticks, they shouldn't just come anywhere. They should either become at the beginning of a line, or they should become at the beginning of a file. And there's a special character for it, this one. And the other backticks shouldn't just end anywhere, but they should end either at the end of a line or at the end of the file, and that's the $sign. And again, we're not going to punish anyone for having some spaces in here. So we're also going to allow a bunch of trailing spaces. Oof, that's a big regular expression, but you see that if you actually build it up gradually, it's not so complicated, and fingers crossed that it's actually correct. And then we're just going to take up this code here, paste it here, up. So we're not going to make the 30 minutes exactly, but we're going to make 35 minutes, and then I'm already pretty proud. All right, and now I'm going to execute this, and what we should see, up, it is not matching, guys. I have a cheat sheet, but let's first try to see if we well, you can say wow, but only if it works, right? Let's see actually what is wrong with this regular expression here. Oh yeah, oh, okay, yeah. So this should match over multiple lines actually. So we need to provide a little bit more information to the regular expression. I forgot that. We need to say re.multiline. This is a flag that we can pass to find iter to modify its behavior. There's another flag, .all, that says, okay, this dot should match everything, including new lines. And now if we execute it, up, we actually do get a match. Here it is. But you see, we only get one match, whereas we would expect 3 matches. We would expect a match for this one, and a match for this one, and a match for this one. And why not? Well, that is because of the greediness, right? So we're basically matching from the first opening until the last closing, but that's not what we want. We want it to be non-greedy. So the code, this bit, should have a question mark behind it to say that it's not greedy. Let's run it. And now you see we get 3 matches that all match basically the 3 code objects that we have. But now we also want to extract the attributes and the actual code. And we're going to do that by naming these things in the same way that we named the word in our example above here. So let's start by naming the attributes. So this is what we want to give a name. How do we do it? Well, in the same way. We say up question mark P, attr for attribute. This should not be there. And then here. And now everything inside here has the name attr. We also want to give this a name because this is our code. And we say up p code. All right, let's actually close this so that we have a bit more space. And the code ends here. So now everything inside here will have the name code. And now what we can say, match.group attr. So let's make it nice actually. Let's say attributes up dot format attr. So we're getting the attributes, which will be a string with all the attributes, and we're printing it out in this formatted string that says attributes, blah blah blah. And then we also print match.up.group code. And then we print just an empty line so that it's nicely separated. And let's run this up. And if we scroll up, you see that it actually really works. So we see attributes, Python capture, right? Let's open the demo thing again, actually really up. So we're seeing that we're matching this. And then later we're going to use that to modify the behavior of our program, Markdown code exec. And we're seeing that the code here actually really matches this. And later we see the same thing, right? Python silent, that's what we matched here. And we got the code as well. Now, this is how far I wanted to go during this episode. So what we've done here is basically we started with a sketch, which sounded maybe complex, but you see that sketch actually is pretty straightforward, right? If you narrow it down, extracting these fenced code blocks from our Markdown is not that complicated. Now, what we have done now is we've captured the code that we want to run. We've captured the attributes that define how the code should be run. And then in the next episode, we're going to continue this sketch, and we're actually going to use that information to do the actual code execution and to actually capture the output of the code execution and include that in our new updated sketch, which will at that time actually almost do everything that we want our Markdown code exec program to do. It will just be a sketch, it will require polish, but it will have all of the functionality pretty much already that we want it to have. And then in later episodes, we will build on that, turn it into a module, debug it, test it, and release it as a nice pip installable program. Now, I hope you enjoyed this first episode of Python Live Lessons. I hope there will be many more. Spread the word also. Of course, I'm all in it for the fame and the personal vanity, so I would like to have as much viewers as possible. So subscribe to my channel and all of those things. And then I hope to see you again next week when we're going to pick up here and keep coding. Thank you for your attention. I enjoyed it, actually. It was fun. It went well, I think. And I will hope to see all of you next week. All right. Bye.